Okay, so we're on to presentation station number 2. You can ignore that bell. I'll wait till the bell and then I'll edit. I'm moving on to presentation station number 2. So here is where we're starting. You want to follow along for credit. So you can open up in your package to where we had the break for this and where I'm going to continue on. Again, so here, now we're talking about evaluating expressions when they have zeros or negative exponents. So when we evaluate expressions is actually very easy. We did this in the warm-up. Basically, it's when they give you an expression. Here they gave us x to the negative 2 power, and they told us x equals 4. So all you're doing is you're going in and you're substituting. So that's the blank, substitute 4 for the x. So instead of x to the negative 2 power, it's 4 to the negative 2 power. Then I just solve it. Remember, anytime we see a negative power, we automatically do 1 over the whole thing without the negative, 4 to the second power. That's 4 times 4, which is 16, 1 over 16. So basically what we saw is anytime you have a number to the n power, you can put a check or fill in that circle, it's going to go 1 over, you're going to keep the n, but if you notice this whole thing is the same as this whole thing, minus, there's no, I dropped the negative sign, okay? When you drop the negative sign, in the denominator, you put it under the 1, so 1 over your base to the same integer, I'm sorry, the same exponent, but without the negative sign. That's the general rule, all right? That's how we got that. So I'm moving on. So this one here says simplify the expression for the given values. Now this is tricky. Look at this expression, is very long. It's negative 2a to the 0 power, b to the negative 4 power. But then they tell us what is what. They tell us that a is going to be the number 5 and b is going to be negative 3. So all I do is go in and substitute again. 5 where I see the a, so 2, negative 2 times 5 to the 0 power instead of a to the 0 power, because they told us 5 is a. And then b is negative 3 to the negative 4th power. So I only put this in for this and this in for this. Then you just do the work. Well, 5 to the 0 power. Anything raised to the 0 power is 1. So that's how I get the 1 here. The 2 stays the same. This became a 1. And negative 3 to the negative 4 power. As soon as I see a negative power, a negative exponent, I know 1 over. So that's how here I got 1 over. This is in parentheses, so I keep it in parentheses, negative 3. And instead of having a negative 4 power, I have a positive 4 power, okay? Now I just do the workout. It seems like, well, it's a lot. It's not that much. It's pretty easy because it's just the same thing over and over again, different numbers. So here, we chose to do this workout first because we always do exponents first. Negative 3 to the 4th power means negative 3 times negative 3 times negative 3 times negative 3. All of those come out to positive 81, and remember there's a 1 over it. So 1 over positive 81. Over here, negative 2 times 1 is just negative 2. So now we are here, and it's negative 2 times 1 over 81. Well, we can turn any whole number into a fraction by doing it over 1. That's how they get a negative out front. 2 times 1 is 2, and 1 times 81 is 81. So they just kind of did the multiplication out step by step. All right, let's move on and see a few more where we have to fill in more information for ourselves. So here's one, and I'll kind of call out, and if you want to help along, that'd be great. P to the negative 3rd power, and it tells us to solve for p if p is 4. So we know that we can substitute 4 for p. So instead of having p to the negative 3rd, I have 4 to the negative 3rd power. As soon as I see a negative power, I have a negative exponent. As soon as I see that negative exponent, I know I have to put 1 over this whole thing minus the negative part. So 4 to the third. Okay? You're going to write the exponent in the denominator as a product. So what that means, product is when you multiply. 4 to the third means 4 times 4 times 4. Well, 4 times 4 is 16, times 4 is 64. And you still have a 1 over it. That's how we got that. What we did from here to here was called simplify the denominator. We just did the work out. Okay? So we substituted 4 for P, and we just did the work like you have been learning so far. Evaluating in these, we're substituting for whatever they give us. So here's one that has a couple more parts to it like we saw 2 examples ago. Our original problem is here. 8a to the negative 2 power times b to the 0 power. But they're telling us we're going to substitute what? A is negative 2, and B. Oh, substitute, this is substitute. Negative 2 for A and 6 for B. You want to get those in so you can kind of get used to substituting and what numbers are go with what. So what we're going to do here, where I see an A, I'm putting in negative 2, and where I see a B, I'm putting in 6. That's the only thing I actually did is I rewrote it with the substituted values. Now I can start to do the work, okay? So the first thing I notice, 8 times here, negative 2 to the negative 2 power, and 6 times 0. So, I'm sorry, 6 to the 0 power is what? 1. Anything to a 0 power is going to be 1. Okay? Oh no. Anything to the 0 power is 1. So when we come over here, we handled this business already. However, let me give you some stuff over here. We're going to simplify expressions. Simplify expressions with exponents. So the part that I simplified first was this 6 to the 0. I also have to simplify this negative 2 to the negative 2 power. Well, my 8 stays the same, but how do I handle negative 2 to the negative 2 power? As soon as I see a negative power, I'm going to say 1 over. 1 over what? Well, negative 2 is in parentheses, so I'm going to keep the negative 2. And instead of having it to the negative 2 power, I keep it to the positive 2 power. That's what we have been learning all week. And we still have out here our times negative 1. So basically, we're going to write the power in the denominator as a product. So the way we do that as a product, we do negative 2 times negative 2. Well, what is negative 2 times negative 2? Anybody can answer. Negative 2 times negative 2.
4.
Positive 4. So this is now 1 over 4. Don't forget I still have a times 1 out here. Okay? We want to simplify. Is it simplify? Yeah, simplify the denominator. So that's what I was just doing here. I simplified this denominator.
So wait, it'll be 8 over 4. Then you just divide, and then you also be 2, right?
Correct. You can do 8 over 4, but I do this. I make this a fraction, I make this a fraction. 8 times 1 is all 8. 1 times 4 is 4 times 1 is 4, which does equal 2. I like your thought, you did it in your head. That's just the correct way. So our answer, our final answer simplified for this whole problem is the number 2. So a to the negative 2, b to the 0, when a is negative 2 and b is 6, the final answer comes out to 2. I substituted and I did all the work step by step. Okay? So continuing on. What if you have an expression and it's backwards? Here, where the negative exponent is in the denominator. When a negative exponent is in the denominator, here's what you're going to do. You want to go backwards. So originally we had this. Any number raised to the negative power is 1 over that number raised to the positive power. Okay? Or if you wrote it backwards, you would say any number, 1 over any number raised to a positive power equals, you'd be right back where you started, the same number to a negative power. All right? So now, if I said to you, it's a negative 8, 1 over x to the negative 8, you want to write it backwards, set up like this. So you would say 1 over whatever's here equals, let's call it x to a power, n power. Well, let's stick with the problem. If you notice you went backwards, over here x to the n power, negative power is where we started. So I know I have an x to the negative something. Whatever the power is here, you're going to put it up here. So they just did backwards. They took it out from under the 1 and they made it exactly what it was, flipping the sign. The way they flip the sign to be a positive is because you're going to end up with a double negative. It's a general rule. So, an expression that contains negative or 0 exponents is not considered to be simplified. It's not in the simplest form. Anytime you have a 0 or negative exponent, whether it's here or in the denominator, if it's in the denominator, you cannot keep it like that. They should be, expressions should be rewritten always with only positive exponents. We're going to see this one again so you can get a little bit more clarity. Let me erase this and show you one quick more time. All we did was work backwards. If x to the negative power means 1 over x to the power, if you work backwards, 1 over x to the power is x to the negative power. If you have a negative down here and you work backwards, you're going to end up with a double negative. So as a general rule, you're going to go and put a positive exponent there. So 1 over x to the negative 8 equals x to the positive 8. It's literally the opposite. Now you have a positive exponent up here. Okay? So let's try some of these and see what it looks like when we do them out. So it says here, simplify 7w to the negative 4. So we would say 7 times, okay. Guys, line up. We have a fire drill. Please walk out the front. Sucks, because now they put all their stuff away.
How you turn this off, Miss Pitt?
Don't worry about your stuff. Yes.
How you turn it off?
It's cutting more lunch too.